Yeah, thank you for the introduction. My name is Thomas Müller. I'm one of the co-founders of aremtech, and yeah, I would like to talk about the sustainable utilization of biomasses and of course of biogenic residual materials. And so I have to disagree. We are not leaving the hydrogen market completely, but I will get back to this topic at the end. And yeah, I would like to start with a short introduction of who are we, what are we doing, and as I said, we are
Thomas, right now
focusing.
we can't see anything on our screens. Actually, I
Wait a
can't
second.
see, but I think it's the same for the others as well.
Sorry for that. Is it
And now
now?
it's looking good. Perfect.
Sorry for that. So yeah, let me just get back to who are we. We are focusing, as I said, on the field of making biogenic residues usable. We want to convert them into energy, into materials that we can use again in different processes. So we are always just another step to make them usable again and to reduce the negative impact, either if it's for circular economy or just for heat or for electricity, of course. And how do we help our customers? On the one hand side, we're looking into the basic materials. How can we use them? What does the customer needs? How does the process looks like? And we can help him with laboratory researches, but also we can develop the whole plant for him and build by the machines, build the plant. So as an small EPC contractor, let's say it like this. And what is the main goal or the main goals? As I said, for us, biomass residues are a valuable resource. So, of course, everyone is talking about wood, using wood to produce heat, to produce electricity. But especially in Europe, we have a huge topic of not having enough wood and not just wanting to burn wood. So we are thinking about regional waste materials. How can we use them? How can we generate sustainable green energy? And of course, at low costs. So comparing to fossil fuels, we have to get a price that is more accepted in the market, because only if the costs are low, companies are moving towards them. Of course, we want to reduce the CO2 emissions and at the end, conserve environmental friendly resources for that. What are different biogenic input materials we can work with? So on the one hand side, we have like wood, leaves, roadside greenery. So it's like solid biomass materials, waste products, natural products, biomasses we can work with, but we can also work with liquids or in a more liquid way, like sewage sludge or manure, or also fermentation residues from a biogas plant. So what do we do and how do we make them usable? Of course, at the most parts, we need to have a drying step. We have the comminution depending on the material size, and if we can use them as they are, it's fine. We don't need to have this step. We can mix them with other materials, so we can make a blend out of different kind of biogenic residues or biogenic materials, depending on their ability for the briquetting or for extrusion or for pelletizing. We can even additionally add some additives to improve their binding abilities or to improve their chemical appearances in the afterwards process after our briquetting. Because, as I said, briquetting, pelletizing, extrusion, like the upgrading of the biomass is just a step for the usage afterwards. So what was our beginning of the company in 2018? We were working on a new technology for briquetting biomasses and residual materials. We developed a whole new machine or technology we can use for different throughputs, but this was just a nucleus we started with. At the end, we are now working the whole process chain, and briquetting is one important part for us, but we are looking always on the whole process chain along the path. Yeah, just some examples to show you how briquettes can look like. And of course, they can also have different shapes and forms and sizes, depending on the need of our customers, starting from 30 millimeters to 150 millimeters in size. But as I said, it's always just a step for a use case, and that's where we are working with our partners, partner companies together. Of course, fuel production is easy to explain. You can burn it and you have heat, or you can use them in a boiler to produce steam and then also electricity. You can use them as an input material for biomass gasification, for electricity, heat, and cold. You can use them in these gasification processes to produce like different gases, also hydrogen. That's why I said we are not completely switching the topic. Hydrogen is also a huge topic for us. It's the orange hydrogen, so from biomass waste materials, producing the hydrogen. Of course, we can also use it for pyrolysis to produce biocarbon, and also producing biocarbon sinks. So this could be quite interesting for companies for the CO2 certificates. And at the end, it can also be used as filling or fiber materials. For the gasification, we are working together with our mother company. They are producing gasifiers, and this is the easiest way to use different kind of biomasses for producing a large amount of heat and electricity. And of course, we are the partners and the experts for the feedstock preparation. And at the end, our partner AHT is working together with us on the whole process with the syngas production, cleaning, and then as well up to the customer with the generation of electricity, heat, and cold. We have different sizes. I don't want to go into much detail, but there are different outputs, electrical power outlets. So the two main sizes are like the 250 kilowatt and the 500 kilowatt, and we can normally increase the output by increasing number of gasifiers. We are currently quite active in the Japanese market. There we have the nice situation that there's too much wood, and they can't get rid of all these biomass materials. So there we have big projects going on with wood and waste material gasification to produce electricity and of course heat. But we also have projects and plants in Germany, France, Switzerland. So also close by. And of course, if you're interested, the first question or one of the first questions could be that we could discuss what the electrical requirements for your company, your facility, your plant is throughout the year, and if there are like any waste materials left over. Thank you for that.
I would say thank you on the side for the presentation. We have a new topic with the biomasses on this point. Actually, my colleagues from the circular economy, they would say they're the only circular economy element on this point is using the residuals for the construction. And we some days ago we had the discussion on what is. Do we have any examples for using the residuals of sawmills or wood product or the green cutting in the construction, like in the topic of construction? Do you have any examples?
We already produced like materials where we tried and we grinded it down so we could implement it into like cement and stuff like that to have small particles filled as a carbon sink within the construction material.
Okay, so it's not the construction material itself,
No.
but helping other construction materials to performing way better. Okay,
Yeah.
that was just a question because I had the discussion. I had it yesterday actually with a guy from Niski.
Yeah.
He's working on a wood network, and we didn't have an answer. So I was quite curious.
It's always a discussion about like to use it as a resource first and then going into the thermal usage of the material. So the typical waterfall, the steps you take before you go into the, but if you use it in the gasification process, you're going back to the roots of the core compounds of everything. So that's the difference between just burning the material where you release the energy and CO2, and for gasification where you produce like the core elements again.
Okay, thank you for the explanation. Yes, and thank you for your presentation.